Good afternoon. Today we're going to learn how to factor a quadratic that doesn't have a leading coefficient of 1. That's what we did last time. This time, if you look at over here, we have this 2f squared plus 7f plus 5, which this leading coefficient is not 1. In the past, when it was 1, we always found two numbers that multiplied to give us this last number, and then we just wrote it like that. Well, let's do a quick example so you'll remember. So if leading coefficient of 1 means this, and it might have something like plus 6x plus 8. And how we would factor this that has a leading coefficient of 1, we would just take this 8, we would find its factors, 1 and 8, 2 and 4, and any other factor pairs, right? And we find the two that multiply to give you this one, but add to give you the middle one. So 2 plus 4 gives you 6, 2 times 4 gives you 8, so this would factor into an x plus 2 and an x plus 4. And again, the order, I could have had the 4 here and the 2 here. The order of the two binomials doesn't matter. Factoring quadratics without a leading coefficient of 1 isn't much more difficult, but there are a couple more steps. So let's do this one we see right here, this 2f squared plus 7f plus 5. So we have a 2f squared plus 7f plus 5. Now we can't just find two factors of 5 that add to 7 because there aren't any. 1 times 5 is 5, but 1 plus 5 is not 7. Plus we need to take into account this 2. So what we're going to do is we're going to rewrite this as 4 terms. So in other words, I'm going to rewrite the 2f squared just the way it is. I'm going to write the 5 the way it is. But what I'm going to do is I'm going to split this 7f into 2f single f terms where I have to put some type of a coefficient in front of them. Now the coefficient, so I'm going to look for a number that goes in front of the 2f's. Now luckily everything up here is positive, so I can instantly put pluses here. So I'm going to plus 2f squared plus something f plus 5. These two numbers obviously have to add to 7. But what the two numbers have to multiply to is not this 5. What we're going to do is we're going to actually multiply this leading 2 by the 5. So I go 2 times 5 and get 10. Now I look for factors of 10 that add to give you 7. Similarly, like up here when I was looking for factors of 8 to give you sum of 6. Now I'm looking for factors of 10, which I got by multiplying the 2 and the 5 to get a sum of 7. And obviously most of you see that it's the 2 and the 5. You wouldn't have to take the time to write the 1 and the 10. But we notice that 2 times 5 gives us 10, but 2 plus 5 gives us the 7. So that's what we're going to put here. We're going to put a 2 and a 5. And that's just coincidental that this 2 and 5 match that 2 and that 5. I want to emphasize that these two numbers do not always match those two. It's just coincidental. Now what we're going to do is we're going to what's called factor by grouping. Factor by grouping. Grouping. Okay? Not L, but grouping. What that means is we're going to look at just the first two terms. So I'm going to take these first two terms, and like we did a couple days ago or last week where we factored a single monomial, ignore the 5f and the 5, and just what's in common with the 2f squared and the 2f? Well, there's a 2 in common with both terms, and there's an f. So what I'm going to do is I'm going to factor out the 2 and the f from this term and this term, leaving just a single f. And now be careful here, I'm dividing out the 2f. So 2f divided by 2f is 1. So I leave a 1. So this 2f squared became this f, and this 2f became the 1 when I factored out this 2f. Now I'm going to do the same thing down here. I'm going to look for anything in common with these two terms. Well, there's a 5 in common. So I'm going to factor out a positive 5. Make sure you put the plus symbol because it's positive. And then when I factor, I take 5f and divide by 5, I'm left with an f. When I take 5 and divide by 5 or factor it out, I'm left with a 1. Now, if you've done this process correctly, this parentheses should look like this parentheses. f plus 1, f plus 1. That's one of your two sets of parentheses. The other set of parentheses is what we have on the outside, this 2f and this 5. So I'd write a 2f plus 5. And there's your final solution, your final factored form. And I want to emphasize something. What we've done here, I'm going to come down here. I had this 2f times something in parentheses plus 5 times something in parentheses. Well, think of this parentheses as a single, entity, and I factored it out, just like I factored out any other monomial, right? So I factored out that parentheses, leaving the 2f plus 5. Well, what was the parentheses? Well, it was the f plus 1, f plus 1. Now remember, the order of these don't matter. That's why the 2f plus 5 doesn't matter if it's behind or in front. So we come over here, we do our parentheses, we type 2f plus 5 in one parentheses, and in the other parentheses we type f plus 1. And again, the order of the two parentheses doesn't matter. Okay, now I'm going to jump ahead because I want to get to some with some minus signs in there, like this one has a minus 2. Okay, but the process is exactly the same. So what you're going to do is you're going to take that 2k squared plus 3k minus 2. You're going to write this as 4 terms. You're going to keep the 2k squared. You're going to keep the minus 2. Now I'm going to break this into 2 terms. But what 2 terms? What we're going to do is we're going to take the leading 2, times it by this end negative 2, and get negative 4. And I'm going to try to find factors of negative 4 that sum to 3. Since my product is negative and my sum is positive, obviously one of the numbers has to be negative and one has to be positive. Since the sum is positive, my larger number will be the positive. So I'm going to do negative 1, positive 4, negative 2, positive 2. Those are my only factors. Obviously, these two, the negative 2 and 2, don't add to 3, but the negative 1 and the 4 do. So I come over here and I break this into 2 separate k terms. So don't forget the k. One is a minus 1k. The other one is a plus 4k. Now again, I factor by grouping. I look at just the first 2 and I say, what's in common with these first 2? Well, they both have a k. So I'm going to factor out the k, leaving now 2k squared divided by k will leave one of the k's plus the 2, right? The 2k. If I divide this k by k, I'm left with a 1. Always left with a 1 when you're factoring out if it takes everything. Now when I factor here, I'm going to be factoring out a, looks like a 2. And I'm going to factor out a positive 2. And I kind of looked ahead because when I factor out a positive 2, this is going to stay negative. This will be positive, so I get a positive 2k. This will be a negative 1. 2 divided by 2 is 1. Don't forget that. And these parentheses, this 2k minus 1, looks exactly like this 2k minus 1. Now I'm going to factor that parentheses in front of the k plus 2. 2k minus 1, that's this parentheses, factored out in front of the k plus 2. And there's my factored form. So I come over here to, I guess I need to do the parentheses first, 2k minus 1 and times k plus 2. And I submit, right? Now, these numbers can get bigger and bigger, like a 9 is going to have more factors, but the process again is exactly the same. I'm going to do 2p squared plus 11p plus 9, and I'm going to first multiply the 2 and the 9. I start there. I mean, you could take the 2p squared, leave a space for the 2 terms that we're going to get from this 11p, write the 9, and now we got to find what this single p term breaks into. So I take the 2 and the 9 and multiply them together and get 18. And now I look at my factors of 18, 1 and 18, 2 and 9, 3 and 6. And I look to see which of these will add to give me 11. Well, the 1 and 18 doesn't, the 3 and 6 don't, but the 2 and 9 do. So I'm going to break this 11 into a 2 and 9. By the way, some of you might be asking, does it matter which one of these I do first? It doesn't. I can do the plus 2p plus 9p, or I can do a plus 9p plus 2p. It doesn't matter. In fact, I'm going to do the 9p first. I would have actually really done the 2p first to line up the 2p's, but I'm going to show you that it doesn't matter which one you do first. I'm still going to look at these first two and say the only thing in common with these first two is a p. So I'm going to factor out the p. 2p squared divided by p leaves a 2p. The 9p divided by p leaves just a 9. Now I'm going to look at the last two. There's nothing in common. Now I'm glad I did it this way, because when there's nothing in common, there's always a 1 in common. And a lot of students will forget that we can actually factor out a 1, and that's what we want to do. We want to factor out a plus 1 from the 2p. So 2p divided by the plus 1 leaves 2p, and the 9 divided by the 1 leaves a 9. And again, if you look at these two sets of parentheses, they are the same. And that's what we want. So we're going to factor that away. We're going to factor away the 2p plus 9. I'm factoring that parentheses and that parentheses out front, so it becomes one set of parentheses, and I'm left with a p plus 1 in parentheses. Now, I'm going to do it again where I flip the position of those two, so you can see we get the exact same solution, and maybe it wouldn't even be as confusing because you wouldn't have this scenario of leaving factoring out a 1. Some students forget that they can factor out a 1, because if I took the 2p squared plus 2p plus 9p plus 9. So again, what I did was I just flipped the order of these two. Now when I look at the first two terms, I have a 2 and a p in common. So I factor out the 2p, which leaves 2p squared divided by 2p leaves p. The 2p divided by p leaves my 1. Look at my 1. And then here I have a 9 in common, so I factor out my positive 9. Remember, if it's a positive or negative, you put a plus or minus sign there. 9p divided by 9 leaves a p, and 9 divided by 9 leaves a 1. There's my set of parentheses that gives me this p minus 1, that when I factor in front, p plus 1, leaving a 2p and a 9 inside the parentheses when you factor that p plus 1 out. You notice these are exactly the same, just the order is different as far as the p plus 1 is in front. And again, it doesn't matter. So I just come over here and type whichever one I want to type in first. I'm going to do the p plus 1, and then I'm going to do the 2p plus 9, and hit submit, and we've done really, really good. If you have any questions, please contact me, and I will help you in any way I can.